So let's take a look at example one for gravitational potential energy. Nice simple one. We have a 10 kilogram mass. It is held 15 meters above the ground, and we will assume this takes place on Earth. So a pretty standard question would be, how much gravitational potential energy does the ball possess at that given location? So in order to calculate that, we just have to remember, well, in general, let's list our variables first. The mass is given as 10 kilograms. You'll notice I wrote the acceleration as 9.81 meters per second squared instead of negative, and that is quite simply because energy is a scalar. So direction does not affect this quantity, so we can just ignore the negative. And we know that the height off the ground is 15 meters. We can quite simply then use our potential energy calculation, mass times acceleration due to gravity times height. And when I plug those values in and multiply them, I'll get, in this case, 1,471.5 joules. And that alone is all we need to do for this problem. We now know how much potential energy is stored in it. Now we can make some inferences about, what we can do with that energy. Do we want to use it down the road to, I don't know, like power something or light up something? We can use that energy for whatever we want now that we have that calculated value. All right, if we want to look at gravitational potential energy example number 2, we can take a very similar situation and maybe find a different variable. So here we have a 100 kilogram mass. It's being held 20 meters off of what we call its planet Q. We only know that its gravitational potential energy is 12,800 joules, and they would like us to figure out what is the acceleration of gravity on planet Q. So once again, we should start with listing everything that we know. So we're given the mass, the height, as well as the gravitational potential energy. What we don't know is the acceleration due to gravity on this planet. But once again, all we need to do is plug what we know into our equation. So the potential energy, which is 12,800, is equal to my mass of 100 times the unknown acceleration times the height of 20. And if I just solve that out, I'll get 12,800 equals 2,000 g. And I can divide both sides by 2,000, finding that the acceleration due to gravity on this planet is 6.4 meters per second squared. Energy is a scalar, so we don't wind up with a direction, but we would know that since this is gravitational acceleration, it does act downwards, so we could either put the negative in at the end, or we could understand if we were going to use this for some other problem, kinematics or whatnot, we should include the negative, but just realize because energy is a scalar, you are not going to wind up with these negatives due to that reason.